Right, we're going to take a look now at solving systems of equations, and you've done lots of this before. You know, when you've solved simultaneous equations, that's a system of equations. That's two unknowns, two equations. So, for instance, solve the pair of equations. So it's a pair of equations, and what we've put this in the context of is linear equations, haven't we? So we've said, all right, so if it's 3x minus 2y is equal to 4, and x plus y is equal to minus 1, now this is a pair of lines. Now, as long as they're not parallel, they'll intersect, won't they, at one place, at one point, and we can find that point of intersection, the common point that satisfies both equations. This is what solving systems of equations means. We're not just, now if we look at one equation here, for instance, infinite number of solutions, as there are with this, but together there is a unique solution as long as they're not parallel. If they're parallel, no solution. If they're concurrent, as in the same line, then there's an infinite number of solutions. But let's go ahead and find this unique solution, should it exist. And the method you've used, and there have been two methods, substitution and elimination. By substitution, if you remember, now we're going to use the same methods for the systems of equations we look at. We're going to look at x, y, z. We're going to look at three equations, so three-dimensional lines and planes, and we're going to look for solutions. X, y, z solutions. So there'll be three, but we're going to use the same method. So by substitution, what that method entails is making x or y the subject of one of our equations. So in this case, we're going to write it from equation 2. All right, so from 2, we're going to say that say x is equal to minus 1 minus y, and then we're going to put that back into 1. So from 2 into 1. Right, instead of now writing x, we're going to write minus 1 minus y, so it'll be 3 minus 1 minus y, minus 2y is equal to 4. So we get minus 3 minus 3y minus 2y is equal to 4. So everything is now in terms of y, isn't it? So minus 5y is equal to 7, and y is equal to minus 7 over 5. And then from there we get x is equal to minus 1 minus y, so therefore we can now find x to be minus 1 minus y, which is minus 7 over 5, which will work out to be minus 5 over 5 plus 7 over 5, which is 2/5. So our solution is y equals minus 7/5 and x equals 2/5. Okay, that's by substitution. By elimination, and you might prefer this method, is just to get either x or y coefficients to be the same or the opposite. So at the moment I have to do something, and that'll be, say, to multiply 2 by 2. So we'll take equation 2, multiply equation 2 by 2, and the result will be 2x plus 2y equals minus 2. 2x plus 2y equals minus 2, if we call that equation 3. Go back to equation 1, 3x minus 2y equals 4. 3x minus 2y equals 4. And that's equation 1. Now if I add 1 plus 3, what we get is, what I've engineered here is an elimination of y. So I'll get 5x is equal to minus 2 plus 4, which is 2. So I'll get x is equal to 2/5, which is what I got right over here. We could work out what y is, but I just want to explain this, or just remind you of the methods that we use. Okay, so when it comes to systems of three equations, or in fact what I'm going to do first is have a look at I'm going to look at a pair of simultaneous equations, but we'll use complex coefficients. So my example, I'll just pause while I write out. Okay, so I've written out the example we're going to have a look at. Solve the pair of simultaneous equations. Now we've got some complex coefficients here, but what we're going to do is use either substitution or elimination. Now, just thinking here, I've got ix here, I've got 2x there. Maybe if I or what could I do? I could multiply, say, I'd have to multiply both, wouldn't I? But perhaps I could multiply this one here through by 2 to make this 2ix, and I could multiply this one through by I to get this as 2ix, and I could use elimination. So we could try that out. 2ix plus, now this is I by 3 minus iy equals 3i, and down here I'll have 2ix plus, now this will be 2 plus 4i, 2 plus 4i, lots of y, and that's going to equal 4i. So we can try that out and subtract, and I'll eliminate the x. So if we do that, I might just need to tidy this up before I do. So I'm going to rewrite these equations here down below. So it'll be 2ix. This is going to be right. So this I is going to go through here. So so it'll be 3i. Now it'll be minus I squared, and I squared is minus 1, remember. So it'll be 3i plus 1y is equal to 3i. And then down below it's going to be 2ix plus, and this is going to be 2y plus 4iy is equal to 4i. Okay, just need to tidy that first one up again. So I'm working in pairs, as you can see here. 2ix plus 3iy plus y is equal to 3i, and I'll write this one here right below it, so that says plus 4iy plus 2y equals 4i. Right, so finally I think I'm ready for a subtraction. So they eliminate. 3iy minus 4iy, I'm left with minus iy. Right, that's subtraction. Y minus 2y, I'm left with minus y. And 3i minus 4i, I'm left with minus I. So from this, I get that y, I could multiply through by minus 1. That would improve things, wouldn't it? So I get y plus y is equal to I. I plus 1 is equal to I. So y is equal to I over I plus 1. Now it's customary to make real the denominator, so we'll multiply by the denominator's conjugate. So now I'm left with I squared, which is minus 1, minus I, over I squared, which is minus 1, minus 1. So I'm left with minus 1 minus I over minus 2, or 1 plus I over 2. So that's y. So I go back in for x. So I'll swing this. This is now my value of y. I'm now going to go over here. X equals, what do we say for? All right. So what I need to do is sub that value back in. So it will be 2x. Go right back in up here. So I've got plenty of space. So 2x plus 3 minus I. Now y is 1 plus I on 2. 1 plus I on 2, that's 3 minus I, is equal to 3. So now we're going to find out what x is from this. So 2x plus, now this is 3 minus I by y. So this needs to be bracketed. 3 minus I by y equals 3. So I need to expand this out, don't I? So we've got 3. So if I work this through, it'll be 3 plus 3i. Right, just doing my expansion. Minus I is there. Now I've got minus I squared. I squared is minus 1, so that turns into plus 1. It's all this stuff here. It's all over 2 is equal to 3. I could multiply through by 2 here, couldn't I? So I get 4x plus, now I can put all this together. 3 plus 1 is 4, plus 2i is equal to 6. Remember to double everything through. So what have I got now? I've got 4x is equal to 6 minus 4 is 2, minus 2i. And therefore x is equal to, if I put this all over 4, 2 minus 2i over 4, which equals, dividing through by 2, 1 minus I over 2. So they're my solution. My solution is therefore x y equals 1 minus I on 2 and 1 plus I over 2. A really big solution, isn't it? If I'd done it by substitution, there would have been an equivalent amount or maybe more of algebra involved. But there's our solution. I'll just pause there. Right, we're going to have a look at a system of 3 equations now in 3 unknowns and have a look at how that's done. So what we've got to do here is we've got to work in pairs. Now we can use substitution, so we could make, say down here, we could make x the subject of this, x equals 6 minus y plus z. We could sub that back into both these two so that we had 2 equations here and just y and z, solve simultaneously there, got our solutions for y and z, and sub back in for x down here. That's one method. I'm not going to go through 2 methods. The other method is the elimination method. We could just look at 1 and 2 here, eliminate z just by adding these 2 equations together. And then we would use another pair of equations to eliminate z from that pair of equations, so that again we end up with 2 equations in x and y, and we can work on those. So I'm going to just work on the elimination method here. So we're going to say, call these 1, 2, and 3, and I'm going to say, firstly, let's add 1 and 2. So 1 plus 2. What's the result of that? Well, it's 5x, 2x plus 3x, minus 4y minus 5y is minus y. The z's cancel, that was engineered. 5x minus y is equal to 9. So there's an equation, we'll call that equation 4. Now, let's look at, we can add 1 and 3, can't we? We can get the same effect by adding 1 and 3. So by adding 1 and 3, we get 3x, 4y plus 5y. Again, our z's cancel, that was the idea, equals 11. That's equation 5. Now, we've got 2 equations in x and y. This is familiar territory for us. And we may as well keep using elimination. So if we take this equation here, multiply by 5, so I've got 5y's here and here, I'll have 25x minus 5y equals 45. I'll just run this one straight across, so I've got 3x plus 5y is equal to 11. And now if I look to subtract, I get 22x minus 5y. I beg your pardon, I'm looking to add because I've got opposite signs. So I'm looking to 25 and 3 is 28x equals, adding here, 56. So I get x equals 2. That's a nice result for us. If x equals 2, let's have a look here. If x equals 2, I can put x equals 2 in here. I'll get 10 minus y is equal to 9. So I get y is equal to 1. Fabulous. Now I just need z, and I can go back into one of my original equations here, and I can see that x plus y minus z, so 2 plus 1 minus z is equal to 6. So z must equal minus 3. And so therefore my solution, therefore my x, y, z solution, x, y, z solution is equal to 2, 1, and minus 3. Okay, we'll leave it there, and we can now get on with the last exercise in this this epic chapter 3. It's exercise 3R, and it starts on page 157. So let's have some fun with that. I'll see you soon.